back. Oh, maybe I should have checked the YouTube description on that video. How do I look at the video? Where is this video? Here it is. Where is this video? Oh, it's already up. Okay, great. All right. Oh, it's already up. Okay. So, what are we doing today? Oh yeah, we're gonna keep going with 29 Edo Nautilus. Last night came up with a kind of a patch. You can hear it. Also came out with a abbreviated scale. It's not the full 14-note Nautilus, but actually a 7-note subset of Nautilus. And you can see all the set values on Surge right here in the lower right one next to my camera. And now that we've got a patch, I slightly tweaked it earlier today, but just barely. But now that we have a patch, I think I'm gonna try to come up with something. This is way too small. I mean, on stream it's fine, but for me it's way too small. Okay. Maybe I should move this down a little bit. Alright, good enough. Okay, so yeah, the patch is it's got this white noise thing on top. I think it's just a wavetable. And then this I just put some effects on this. What do we do on this? So this one in the middle, the oscillator 2, is kind of the main sound in this patch. So if you take this out, it's pretty tinny, and you can hear, I mean, you can see these moving. This one's not moving, but it is active. It's just nothing's modulating that wavetable or whatever. So yeah, what is this? Envelope 2. And we put some distortion on there, which I really like. This distortion, this linear fold type. And this is being modulated through the pressure. So on this keyboard, if more of my finger is on the key, that pressure value right here, you can probably barely see that, it rises. And so I can affect this even after I hit the note. So in that way it's different from just plain velocity, which the velocity is affecting the wave frame of oscillator 2. So how basically how hard I hit this note in the beginning, or how much my finger is on the note in the beginning when it first gets the key trigger, I guess, that determines the velocity. So on this keyboard, these two are very much related. like I can't do a side to side wiggle for pressure. And there's no like extra key depth or anything like that. But I think that's how it works on some keyboards. I'm not really sure. I don't have one that does that. But yeah, it's direct. It's basically velocity is just almost like whatever the pressure is. It's the same reading, just at the very beginning of the note sounding on. But anyway, so I put a lot of the pressure stuff on that distortion. And then I put a little bit on... No, that was it. So yeah, a lot of that on there. And then the velocity I put on this, which is like the main sound. And the reason I did that, or decided to keep that, is because when is it bypass? Yeah, is when I didn't have it on. I don't know, it just sounds like more disconnected from the distortion, I guess. And when the velocity is changing this, I could have set the pressure to this too, or instead. I could even put a little bit on there. Anyways, like just a tiny bit. I think I like it. We'll see. Actually do. Yeah, it just helps the sound to blend more with the distortion. I don't really like a fuzzy sheen, like overlaying the sound type of distortion. I prefer when the distortion kind of feels like it's part of the sound more, if that makes any sense. Make sure there's nobody chatting. Okay, so anyway, the goal for tonight, if I can say that there is one, is I want to try to come up with something now that we've narrowed down the scale and found a patch. So I think now that we have a sound and a scale, I'm just gonna try to come up with some sort of idea, maybe just like a chord progression, and I'm not sure if I want to just actually record it on the keyboard or maybe even just put it in piano roll and kind of adjust the velocities manually. I'm not sure what is going to be a better approach for me, but I think I'll just start with, I guess I'll start out just letting it record. I'm going to improvise some stuff. And since I'm pretty much settled on the sound, but might want to tweak it later, instead of recording the output, I'm just going to record the MIDI. To be safe, I could record both, but I think it'll be fine. So yeah, I'm just gonna try to come up with some stuff using this little 7-note subset. And the 7-note subset that I kind of settled on is well, I'll pull up the where'd it go? Oh, it's right here. I'll pull up the Zen wiki and find the bit on Nautilus. Hello, Alfredo. Welcome. Yeah, the reason I chose this 7-note subset was based on something in this on the Zen Harmonic wiki, which said, "Hey Alfredo, I've got a scale picked out. It's a subset of a subset. Basically, it's a microtonal scale, and the main tuning is 29 equal divisions of the octave. So basically, instead of splitting the octave into 12 notes like you would see on a keyboard normally, in 29 you split it into 29 little tiny slivers. And since that's a lot of notes, kind of narrowed it down to this Nautilus scale, which you can see right here on the Zen Harmonic wiki. It talks about the Nautilus scale. That pattern is one long step, which in this case is 3 steps of 29 Ito, followed by 13 small steps, which the small steps are 2 29 Ito steps. So it's like a 3-step interval and then a 2-step interval, 2-step interval, 2-step interval 13 times. You add that all together, it makes an octave. It makes 29. Yeah, it's kind of it's a lot, but because it's a lot, and I'll play a little for you. So if you look at my keyboard, here's a C, or I don't know if the note is C, but here's some note. It looks like C on the keyboard. Then the octave is the next G. So what we did is took a 29 note division of an octave and shrunk it way down to make it actually smaller than a 12 equal division. So this is a 7-note scale. So from C to G on my keyboard, or you take any what looks like a fifth on a keyboard, you'll get an octave. So yeah, and in fact, if I change the sound on Vital, let me make sure this is saved. If I just initialize the patch real quick, you can probably hear the octave a little clearer. So hopefully that's not too loud. And then the scale is going to go. So that's like a 7-note, kind of like a do, re, mi, fa, sol, la, ti, do thing. And if you see next to my camera, the I have Surge loaded up too. It's not actually creating any sound, but I'm routing Vital to Surge so that you can see the sense the interval cent sizes of every note that I'm playing. So in this scale, see the 2-1 lights up. That's the home note of the scale. And then the next note up, it's lit up in orange there. That's 165 cents. So it'd be like on a regular keyboard, it'd be like halfway between. If your first note was a C, that second note would be like roughly halfway between D and D flat. Because normally every note is 100 cents. So if we take the tuner off of this, that's normal. That's what most music sounds like. Oops, wrong one. But in this instance, we've shrunk that, but also found a lot of different intervals. So anyway, if you do want to know more about just basic microtonal stuff, I don't mind explaining more, but this is kind of several steps removed from the very beginner stuff. It's definitely not the most advanced thing, but yeah, there's just different ways to split up an octave. And you can get a lot more notes than just the notes we normally hear. But yeah, if you have any questions or anything, feel free to ask. But in the meantime, I'm gonna keep going. So yeah, we settled on a 7-note subset of this Nautilus 14 scale, which, as I was just explaining, the Nautilus, the full thing is this pattern. But it's set on here 14-note mosses. So a moss is just a type of scale, short for moment of symmetry. And I think it's comes from Irv Wilson. Is the music theorist who sort of first started exploring these. But basically, like, the diatonic scale is a moss. So this here, you can apply this sort of pattern to several different Edos, different divisions of the octave, or different divisions of any interval. And you can apply that pattern and come up with different scales. So the normal major scale is whole step, half step, whole step, whole step, half step. So on a normal 12-tone piano or whatever, that's the major scale. So that's 5 long steps. That's those 5 whole steps and 2 small steps. So when we talk about mosses or moment of symmetry scales, we usually reduce them to that form. So, or we talk about those step sizes in this way. We use L and S, and sometimes there's a 3rd or 4th step size, but you know, most of the moss scales that microtonalists use and are have long and small steps. So this Nautilus scale is like another version of that. So point being, you can play a diatonic scale, the 5 long, 2 short scale, in many different tunings. So you can play it in 17, 19, 31. There are a lot more, but I can't. 22 and 27. I think in 29 too. and this is just a different scale, so it's not the diatonic scale. It's obviously a much different pattern because it's 13 small steps and one long step. But here it says 14 note mosses are worth looking at because taking every other note of them gives a heptatonic. Meaning if you have a 14 note scale and you skip every other note, kind of like skipping every other note on the piano gives you a whole tone scale. Which whole tone scale is of course a 6 note scale. On the piano it looks like this. So if you can see that on, I don't know if that's showing up. I don't know if that's intelligible or not, but all the whole steps create a whole tone scale. So this is kind of like the 14 note version of that. And in fact, if the full 14 note Nautilus is loaded up on the keyboard, to play a 7 note subset, you would play literally a whole tone scale on the keyboard. But what I did last night was took that whole tone scale and I moved it. Where's the MIDI? So let me get the browser out of the way so you can see this. So if you look over here in the MIDI, these are all, and I changed the tuning so you wouldn't be able to hear them now. But each one of these is one mode. It's one 7 note scale in 14. So there's 14 of these. And I'll play that real quick so you can hear what it sounds like. And if I can find Vital. There we go. See, I'll load up the regular Nautilus, and then you can hear these different modes. Put a little filter on this. So that's one mode. And then the second mode. And these are just triads of that 7 note scale. And so it's, if you're familiar with music theory, this is kind of like starting on the C major scale and then going up through all the C major chords and then like going up to the C sharp major and going through all those chords and so on until you get through all 12 of the patterns. But there is a sort of a difference because it's actually more like starting on the C scale and then going to the Dorian scale and then going to the Phrygian scale. It's sort of like that too, because the actual pattern here changes, although it doesn't look like it, because the size of these steps is uneven because there's one long step. So on the piano roll, the distance from here to here is larger than the distance from here to here. but the distance from here to here, here to here, most of these are the same size because most of these are that small step. 13 of these is that small step, but every 14 notes there's one large step, which is just a little larger. Anyway, I'm sure that's a lot to keep track of, or to try to keep track of, but part of the reason I'm doing this is just so people who are interested can start to wrap their heads around it, or kind of see what you might do if you get involved in this, what the process might look like. Anyway, so what I'm going to do now is go back to our 7-note subset. So I chose one of these modes, and the mode I chose was, out of all these on the MIDI roll in the top left, I chose the which one was it? The 12th one, which is right in this zone. So we can't hear it anymore because it's not tuned correctly anymore. But yeah, I think it was that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, I just took that step pattern and put it in Scale Workshop and made a tune file with that, which now is in Vital, which is why we can play it. So yeah, now that we discussed all that, I'm going to go back to the patch, because the other thing I've been working on the last couple nights on the live stream is coming up with a patch. Well, mostly last night. So I have pretty much settled on this patch. So now that we've got a patch going and got a very small, easily manageable scale, I'm gonna start just noodling around and try to come up with, some chords or something. Try to come up with something to just get the germ of an idea. So I think I'm just gonna noodle around and see what happens first. So I think I might try inputting some MIDI on the piano roll and manually adjusting some of the velocities. So I don't know, this actually might not be enough notes. I thought maybe narrowing it down to 7 would make things a little easier. But it's not. So okay. Almost reminds me of like bagpipes or something. I don't know if there's a way to adjust the pressure in MIDI roll, probably, or in piano roll. So, let's see, is it better to try to play this? So that's that one. What is this? That can't be right. F sharp, A, C sharp. It looks so wrong, but it's not. It's because the geometry of the keyboard is deceiving. Anyway, what was that first one again? I think it was C sharp, G, B. So it looks like a half diminished. That looks like a F sharp minor. This looks like an A flat augmented. Is that really right? Oh no, that's a D. Oh, that's a D diminished. Yeah, I like playing it more because it's just easier to do the pressure. But I might just try to write something on MIDI roll and then actually play it physically. I've never really tried doing that before with keyboard stuff. Yeah, I could probably repeat. Oops. Except maybe this. And then does this again. And then does something else here. So this is what I'm thinking. The first chord's probably going to be the same. And then we're going to go down instead of up. hearing like a... Yeah, maybe that's kind of corny, but alright. Yeah, it's pretty corny. Maybe it'll sound a little better when I learn how to play it. So, try to play it. Oops. The camera on this peanut roll is so annoying. So I remember this was this. And then what's this? F sharp way up top. That sounded right. And then just that again. And then what's this? C F sharp. So it looks like a it just moves up one. So it looks like a C7 flat 5 sort of thing, and then moves up a half step. And then this is not exactly the same. This is like F sharp major now. Interesting. So yeah, okay, let me see if I can learn this, and then maybe I'll play with the rhythm too. That's the hardest part. So, alright. I'm just gonna... I mean, I'm thinking this will be more like the just the backdrop chord kind of stuff. So I don't know how crazy I want to go with it, but of like that too. I wonder if I think what I'm gonna do is kind of record like a straight version of this. I'll set a click. Make sure it's not too loud. I don't think that's gonna be too loud. And yeah, I'm just gonna try to get a relatively clean take of what we came up with. So the pressure and all that stuff's in there. I think it should be. And yeah, okay. So I'm gonna try that. And then we'll see if it is loopable. What's going on? No, come on. So we'll just slice that. Slice that. Does this look right? No, sure doesn't. Oops, what's going on? Alright. I guess it's a little obnoxious, but for a microtonal thing, that's kind of just part of it. Usually. Anyway, so I think that sounds better than the straight meaty. Maybe we should try a faster one. I don't know if I can play it that fast. I probably could, or at least get a take, and maybe just kind of micro adjust the MIDI. Yeah, I keep forgetting. It's too fast. So close. The ending I messed up. Do I want to do this? Kinda. I did get a good take, I think. Good enough, right? Where to start? Where'd it go? Oh, it's a separate, man. The way your Reaper does MIDI stuff is so... I don't know if other DAWs are the same way, but it can be so stupid. Starting right here. So I'll split that. Oops. And then split that as well. That does not look like a clean loop. But maybe we can tidy it up. Why did it paste up there? Come on. It's just absurd. Alright. Actually works fine. So that's something. That's something. Not my greatest idea, but it's some, could add some layers to. So I was maybe coming up with some other ideas though. I should record everything I noodle on in case I forget. And no click though. something like that. I feel like I could try to sing on or something. It makes me want to try to sing on it. So I like stuff like that. Yeah, I'm actually surprised. I'm starting to get kind of nervous. Looks like it looked like YouTube was cutting out. It might be fine though. I think it's fine now. I don't know what happened. But anyway, yeah, I think I'm very curious what we might find if we just noodle on this a little more. I kind of like this. Kind of like some of the stuff. It has some very I guess stereotypical Zen sort of. That's pretty Zen. It also has some kind of what is that? yeah, it's kind of fun to just noodle on. I wonder if I should set up a drone. Maybe come up with like a drone or some kind of ambient, but relatively stagnant texture. To be fair, this patch sounds kind of drony. I mean, it sort of reminds me of bagpipes a little bit. But I wonder if I should just come up with like a riff and then make a bass line or something. That's hard to play. definitely don't hate everything about that. I haven't really narrowed down anything, but it's kind of nice to just jam on it. The fact that it's a smaller scale makes it pretty playable on this little tiny keyboard. A weird thing about doing like a 7-note scale is pretty much just play chromatically, and but it's hard to keep track of the notes. So on I mean, that's our root, so that's our root, so that's our root. So it's like 1, 2, 3, 4, 5, 6, 7, 1. 2, 3, 4, 5, 6, 7, 1. So it looks like if it looks like a half step, it's just a second. And then looks like a second, it's a third. Looks like a minor third, it's a fourth. Looks like a major third, it's a fifth. It looks like a fourth, it's a sixth. It looks like a tritone, it's a seventh. If it looks like an eighth or a fifth, it's an octave. So you don't get as many intervals. And they're all kind of right there. I did notice while jamming these stacked thirds, which would be fifths in this case, sounded pretty cool. I like these. So yeah, those were cool. They just look like augmented chords. Yeah, those sound pretty good. So it looks like an augmented chord, but it's just a stack of fifths. It's like a big fat jazz or guitar chord. One thing I noticed about the way this this pressure works on chords. So if you look at the vital screen right here, this one in the top right, this pressure thing is if you play a chord, the pressure only responds to the last note I play on this Micro Freak. So if you play and then move this low note, it does nothing. If I wiggle that top finger, it'll adjust the pressure on everything. But I do believe this keyboard on its own I'm like 99% certain that when you play the Micro Freak standalone and just use the onboard sounds, when you're not using it as a MIDI controller, the every note you're playing has its own pressure and velocity. So when you're just doing the Micro Freak, you can adjust all the notes of the chord differently. but using it as a MIDI controller, I don't know if it has to do with, I don't know if that's always the case or if it's just vital or how that works, but yeah. It reads the pressure on the last note I played, but not any of the other notes I've played. So, having found this cool it looks like an augmented chord. Now I'm wondering like what other shapes sound like. So if we just stick with this shape, and just like with the full Nautilus scale, this 7-note subset of Nautilus, it's uneven, so not every step is the same size here. I can't remember which one the big one is, but if we look at the synths, we should be able to figure it out. So the first, oh actually this would be way easier to do in Scala. Oh, I don't have it pulled up anymore. Can't remember if you can. I mean, I could just copy and paste it into. I said Scala, but I meant to say Scale Workshop. I'm just gonna pop it into Scale Workshop. So yeah, looks like the biggest step is here to here. So this 0 is this note, and then this is this note. I'm sorry. So yeah, so oh, you can kind of hear it. So you can see if you just look at this column, this is every mode of this 7-note scale. So here's like the home mode, and then this is like the first mode or whatever, Dorian or whatever you want to call it, and then this is the next one, and so on. So you can see from the second to the third note of the main scale. So here's note 1, 2, 3. That's the big interval. So anytime we cross that big interval, we're going to get a larger step. So regardless of what our interval is, if we cross over that part, or its octave equivalent, so if we cross over here to here, or here to here, or here to here, we will have a big interval. But everything in between is small. So everything else is the smaller step, which is not that much smaller. It's 165.5 versus 206. Curious what these intervals are actually. I I guess I'll pause the recording momentarily, and since we're getting curious, we'll do a little more theory stuff. So what was the 165.5 interval? So if you go on Zen Harmonic Wiki, there we go. Oh, that side thing is like built in. Interesting. Alright, so if we go to Zen Harmonic Wiki, is this large enough? Like, is the font big enough? Maybe I should make it slightly bigger. That's probably big enough, right? Check YouTube. Could read that if it was in... Oh, I can read that, yeah. If it's in full screen. Alright. If you want to read along, I guess you have to full screen. I mean, I could make this a little bigger. So, how does that look? Wow, YouTube has crazy delay. That would probably be legible in a lot of instances. Okay, so I know we had this 206, so that's yeah, it's basically just stacked. So an interesting thing about 29 is it has a really clean fifth. It's even cleaner than the 12 Ito fifth. But it's, so our normal fifth in 12 Ito is a couple cents flat, which is really close. So it's a really good sounding fifth. Sounds like a fifth. You could get a cleaner fifth, but it's pretty clean. The 29 Ito fifth is only 1.5 cents sharp, but it's sharp, so it's on the other side. But yeah, it's just 0.5 cents closer, which anyway, the fifth sounds really clean. Do we have any fifths in here? Yeah, we have some of these. So from here to here is that's all four of these are perfect. Kind of wolf fifths, and you can hear. So these other fifths, the 620, the 662s right here, you can tell these are kind of out of tune. So you can kind of hear it. You can hear how grindy that is. You really hear that one. So those are the bad fifths, quote unquote bad. There's a clean fifth. So hopefully you can hear that. These are much more stable sounding than these. So back in the ugly ones. So if you were just to go up in fifths, you'd have 4 nice, shiny, almost perfect, just slightly sharp fifths. And then you'd have 3 kind of nasty wolf fifths that you could still do interesting things with. But if you just want a nice clean fifth, those would not be your choice. Yeah, now that I'm looking at this, you can see we only have 2 small step sizes, and then the same holds true for the inversion, which maybe should be obvious, I guess, but I didn't think of that. So you have 2. Well, you have 2 at every type of interval here, because we have the small and the large steps in Nautilus, and we just have 1 large step, so that only will offset everything at 1 point in the whole scale. So we only have 2 of these interval sizes for each type of interval. So everything in this first column, it's a type of second. So this 200th second, that's a major second. That's more or less a Pythagorean major second, just maybe a little sharp, just like our fifth is a little sharp. Probably 3 cents sharp, because our fifth is 1.5 cents sharp. So if we look at that 206 interval on ZenWiki, it pulls up the 9/8, which is it's about 204. You round up. That's the Pythagorean whole tone, or major second. And you get that interval by stacking 2 3/2 fifths. So 2 perfect fifths. So this interval we get from stacking 2 of our nearly GI fifths. We still call this perfect fifth. So yeah, we have a slightly sharp fifth, and hence a slightly sharp ninth. This interval here, which we have a lot more of, is a less normal interval to I guess to us Westerners or whatever. Not that I know of anyone who uses it. I don't know who uses it or doesn't. But 165 cents. It's almost right in between a major and a minor second. So when you have an interval that's a third, sixth, second, or seventh, that is normally defined by major and minor qualities. If there's an interval that sits roughly between those 2 qualities, we call it neutral. So while this is kind of leaning on the major side, it's pretty close to neutral. So these intervals here, we'll see what they say, but I suspect at least one, if not all of them, will be some type of neutral second. So 1211 is the undecimal neutral second. So the undecimal, this is just a fancy math term, meaning having something to do with the number 11, because this is an 11 limit interval, meaning that the highest prime number among these two numbers here is the number 11. So the number 12 is 2 times 2 times 3, so 2 squared times 3. So that's a 3 limit interval. Is that right? Yeah. And then 11 is just 11. It's not divisible by any other number. So we say it's prime. And every time you have a prime number in the harmonic series, it introduces a new sound. It introduces a new scent value. So for like every new interval introduces a new scent value, even if it's not prime. But some intervals can be broken down into the smaller intervals. So if you were to stack smaller intervals, so 12 for instance, the 12th harmonic is just the third harmonic 2 octaves higher. So it's not really like a new sound. You could octave reduce it, and basically it's just the sound of a fifth compared to the fundamental. The 11th harmonic, though, there's no lower harmonics that create this sound. It can't be broken down into a combination of lower harmonics. So every prime number is like that, and only prime numbers are like that. So every time you have a prime number, you are introducing new sounds. Because of this, microtonal music theorists organize just intonated intervals and sounds into what are called prime limits. So 1211 would be an 11 limit interval. And when we are talking about 11 limit intervals, we'll usually use this word undecimal in reference to those. It says here it's also known as the lesser neutral second. That has nothing to do with the limit. There's just another neutral second that is probably already in a lower harmonic. I'm not sure about that. It might be a higher harmonic, actually. But there's some other neutral second in JI that is slightly bigger. So this one is almost exactly 150 cents. So if you're in like 24 Edo, you have a really good, like within half a cent, accurate representation of that. If you were to lay out 24 Edo on a keyboard, every key would be 50 cents up. So this would look like a minor third. It would look like C to E flat if it was in 24 Edo. It says here 1 step of 8 Edo is an excellent approximation of the just neutral second. What the heck? So, hold on, Windows got mixed up. Why is that? Oh, each one is 150. Okay, that makes sense. So 1 step of 8 Edo is 150 cents. So this is not really that close to 165. We're 15 cents sharp of that. So 1110, here's another one where 11 is the highest prime number, so it's another undecimal. This is the large undecimal neutral second. Oh, that's so the and this one's spot on actually. This is 165. So we're actually half a cent. We're just as close as the 8 Ito step is to the 1211. And then the 10-9 is a little sharp. So this is not 11 limit. I don't know. And this one is we're what is this, 17 cents off of this. So if you were in this is 5 limit, because 9 is divisible by 3, so that's a 3 limit number. And 10 is divisible by 5, so 5 times 2, so that's a 5 limit. So altogether this is a 5 limit interval. And in 5 limit just intonation, 10-9 is the small classical or Ptolemaic whole tone of about 182. So it's a little shy of the 12 Ito, which is 200 cents. 12 Ito is pretty close to 9/8, because our system comes from, the 12 Ito system comes from stacking fifths. So if you had to like put a limit on a 12 Ito, it would more or less be, be good at the 3 limit, not really good at anything past that. Or it's okay at the 5 limit, because it still has like major and minor thirds and stuff that shows up in the 5 limit, but they're relatively far off. Like the major third is like 14 or 16 cents off. I think it's 14 cents off. So it's still there, but, and then I think the minor third's like I never can remember what a 6/5 is. It's only 15 cents off. Maybe almost 16. And then just double check. The 5/4 is like 386. Okay, so 14 cents, 16 cents. So roughly 15 cents away from the 5 limit, so that's not terrible. But there's way better approximations to those intervals in other keys. And as we can see here, this 29 Ito scale has a really good 11/10, because it's half a cent off. So that 165, which we have a bunch of, yeah, it's barely off at all. So we have it here, here, and here. So we have a lot of these. And then this one you can hear how normal it sounds. Sounds like a normal whole step. But yeah, I do like this step. It's interesting. And yeah, that's kind of cool. So we only have one of the major seconds. The rest of them are the large neutral, undecimal neutral seconds. And then on the other side, we have the inversions of those intervals. So that would be like a Pythagorean seventh, I guess. And then these would be 11 limit neutral sevenths. So neutral always becomes neutral, but since this is kind of a skewed neutral, kind of skewed sharp, this one's going to skew flat. So I'm kind of interested to see what that is, that 1034 and a half. So I'm assuming the second one's going to be really close. Yes, so it's the small undecimal neutral seventh. So the large undecimal neutral becomes the small undecimal neutral, and vice versa. The small undecimal neutral second would become the large undecimal neutral seventh. It's also called supra minor. So supra minor is like a sharp minor. Supra minor, but a little towards the neutral. And yeah, there's not a lot of info on it because it's a anything above a fifth is not going to get a lot of attention. Because all the focus is going to be on the smaller inversions. Let's hear what it sounds like in the browser. I think our browser volume's good. So yeah, we have that. All right, here. It's pretty much in tune with it too. That's funny. So yeah, that sounded just like that. So that's good. And then we have this one. If we start on the third step. So we have these lesser undecimal neutral sevenths. As soon as we get here, we have this Pythagorean seventh. I'll just look at 16/9. It's Pythagorean minor seventh. 3 limit just intonation. It's just 2 perfect fourths. So a fourth is just an inversion of a fifth. So just like you stack 2 fifths to get a ninth, and the inversion of a ninth is a seventh, you can invert the fifth, stack 2 of those, get the inversion of the ninth. That's kind of interesting. I've never put that together. Is the octave reduced form of the ninth subharmonic. So yeah, subharmonics are just literally just the mirror image of the JI intervals. So normally just intonation intervals are positive, or numbers 1 and above. So they're always numbers between 1 and 2. If it's subharmonic, you flip the fraction, so it's always going to be between, I think, 1 and 1/2. I think is the way that works. Yeah, something like that. The interval is always going to, the actual value, the arithmetic value, is going to be between 1 and 1/2 if it's a subharmonic. So subharmonics are tones that are actually longer than the fundamental. So the frequencies of a subharmonic, the frequency of a subharmonic is a longer wavelength, and it's a slower frequency. So it's a lower tone. Whereas harmonics are generally in the compared to the relative to the fundamental, harmonics are always adding frequency, going fast. They're always faster and shorter wavelengths. So compared to the fundamental, you can think of subharmonic as kind of being in the negative region, the fundamental being at 0, and the harmonic series being in on the positive side of the axis. I don't know if that is helpful or mathematically coherent, but it's just sort of how it is. So yeah, kind of just interested in this. It's like a cute little subscale of a subscale, and I kind of like that it's got 2 of each type. So as we go inwards on the chart, so you have unisons and octaves on the outside. Here you have 2 types of interval, but you only have 1 exception. So you have the majority interval, which is the neutral interval on either side. Then you have the major second, and then the minor 7th here. And then here we have this 331, which I'm pretty sure this is like really close to that Zeta arose novum decimal minor third, which I looked it up, but I keep forgetting what it is. I think it's 23/19. I believe it's 23/19. If we go sense to frequency, just type in 23/19. Oh, we should find the it'll be a negative because I did it in the wrong order, but yeah, it's almost exactly the same. So negative 330.7. Here we have 331 on the dot. So you can ignore the negative. It's just I wrote the intervals in the wrong order. I wrote them how you would write it on paper, and they want you to do it differently here. So yeah, 330.7. So that's a really good approximation. I'm not sure if there's a better one. If there is, it almost makes no difference. The two are just almost exactly the same. So no, this is not close. That's 347. I mean, it's close, but not as close. I mean, that's 315. So yeah, that 23/19. This is pretty much that. It's a cool sounding interval, and we have a few of them. You don't have it here. You don't have it here, but you have it here, here, and here. So that's like a sharp minor third. So we have these minor thirds here. And then this is a really interesting interval. I was looking at it earlier. And yeah, there's no good lower limit approximations to this one, and I don't know of a higher limit one. The 372 This is 359. And this is like 384, 386, I'm sorry. Let's get that confused. And I want to say I wonder what would happen if I just type in 372 cent interval. Nothing. Can you find on the page? Find. What was it, 372? No. Looking for a cent value. You're not going to find a super particular ratio that's that wide. These are all going to be relatively small. Oh, that popped up. Is there one close to that in here? No. Oh, it's this. Oh, 22 has a nice page. Oh, this is Wikipedia. Why does 22 get its own page? I love 22. I'm just curious. I guess I don't know much about it. History and use. Seems to have originated with 19th century music theorist R.H.M. Bosanquet. That's, is there a keyboard based off this guy? Inspired by the use of the 22 unequal division of the octave. In India. Oh, that's interesting. You know, I think I've heard that actually. Bosanquet noted that a 22-tone equal division was capable of representing 5-limit music with tolerable accuracy. Which, yeah, that's a limit. I mean, a limitation of the of 12 Ito. It's not. It's okay, but it's not great at 5-limit. It's really only good at 3-limit. Possible next step after 19 equal. Contemporary advocates include music theorist Paul Ehrlich. That guy is, he runs the Microtonal music group. Very, very helpful person. And obviously smarter than probably everybody else doing this, or 98% of us. Because he does actual science. But, yeah. Anyway. Yeah, and he's done stuff with 22. I do remember that. Contemporary advocates of 22 include music theorist Paul Ehrlich. I don't know if I'm saying his name right. But, anyway. That's cool. Well, I was looking for a good representation of this interval, but that's kind of what makes it interesting, is that I haven't found it. So we have a couple of those. So we have it here, and we have it here. But yeah, it's like pretty flat for a major third. So if you hear the full chord, It's a major triad with this interesting major third, and we have another one right here. So yeah, that's our second, this is our third, this is our fifth. So if you look here, you can see kind of by looking at the, no, this is our fourth. What am I talking about? This is our fifth right here. But if you look at the 0, 2, and the 4 column, I don't know why I said that about the fourth, I was just wrong. But yeah, if you look at this in the fifth column, so you can see this is the major, because our fifth is normal. Fifth is normal. Then we have these three kind of ugly fifths we were talking about earlier. So here's a good one. Here's a good one. Here's that crazy one. Another one. As you can hear, they're pretty dissonant. And but you know, we have a few of these good ones. But yeah, if you add the third to the mix there, we have a major chord, a major chord. Now here we have this funky fifth, so I'm just going to call that diminished fifth. Call this a minor third. So this would be like a diminished, this is almost like a minor fifth or something. So you have a diminished. There's three of these diminished in a row. But then you have like a minor with this nice, I guess this is like a, what did we say this was? 23/19. This is like a 23 limit minor third. I'll just call it the novum decimal, even though it's whatever the fancy math term for 23 is, decimal. Because I remember it from the from Zio Rose's 12-note scale that uses this interval, and she calls it novum deca or novum decimal or something. And then we have another minor third. So we have major, diminished, diminished, minor. And then if we want to have one more, we'd be back to major. So two majors, three diminished, not necessarily what you want out of a scale, and then two minors. But to its credit, I mean, two majors and two minors is not bad. And who doesn't love a good diminished? I don't even know if you can really call this diminished. That fifth is weird. Normally you'd have, so in 12 you'd have a 600 cent interval on the top. So I mean, this is extremely wide compared to that. I don't think this is standard jargon, but I'd call that like a minor fifth maybe. I do think that term exists, but I don't know how common it is for this sort of thing. So what, I'll actually look at that 662 on the 29 page and see what they say here. So 1611 is 648. They call that an undecimal sub-fifth. So that's interesting. I've never heard that term before. It's exactly between a perfect fifth and a diminished fifth when it's 650. So this is a little sharp of that. So we'll see what the other interval is, see if it's closer. It's another 11 limit. 663. Oh, that's really close. What do we have? 662? This is 663. This is extremely close. So yeah, we have quite a few good 11 limit intervals because our second and now this fifth are both 11 limit. Because our second, seventh, and fifth, which also means the inversion. So the second, fourth, fifth, and seventh are all have pretty nice 11 limit intervals. So this would be 22. I mean, really close to. This is really close to 2215. So yeah, it's extremely close. That's interesting. So that's it there. And where do we have one of these? On our third step, we have one. Do we have one on the next to last? No. We have about a third, fourth, and fifth step. And then, so. That'd be sixth. So, this is our first. Second, third. That'll be our highest. I don't know if we have that, I don't know if I can match the pitch. No, I can't quite make it. I mean, it's right there, but. Can I actually, can I change how much that will, it's only going down a cent. Can you change that? It's not a big range. I don't know if you can change that. Advanced. Huh, I don't see it. I know on Surge you can actually make the pitch wheel move more. And this one's only going up to 100 cents, which is like barely anything. Anyway, whatever. We're not going to hear the perfect one-to-one. But we have that interval. So, man, I'm getting a little tired. I don't know if I want to stop or just take a little break. But yeah, my brain is getting tired. I kind of want to jam more, but I'm so close to analyzing all these intervals. I have to get up really early tomorrow, so... Well, not really early. Right now is really early, but I'm not going to get much sleep. And I guess because I should stop soon, I'm going to take a really, really quick breather and just eat a banana so I can focus a little bit before I stop completely. But yeah, I'll probably wrap up in like 15 or so. I'll be right back. Alright. So, yeah, I'll just eat the banana. Because I'm not going to be here much longer, so. Or I gotta wrap this up soon, I mean. So, yeah, I found an identity for this. No, I didn't. I wish I did. My subconscious. Found an identity for what? The 662 is the 2215. Yeah, it's a cent off of that. So, and then this is just the Pythagorean fifth, more or less. Just the JI 3/2/5. So we already know without even looking that these are just the inversion of that. So this is just the 4/3, fourth right here, just a cent and a half off. And then this is the inversion of this 22 10. So what would that be? Make it. What is this 22? What the heck was that? I was just looking at it. No, I mean that 1511. It's the inversion of this 1511. So, no, 1511 is the inversion of this 662. Oh, 2250. That makes sense. Just double the one. I don't know why that wasn't obvious to me. Just double the lower one. Put it on top. That's how you find the inversion of any interval in JI. So the inversion of this would be 2618. Well, can you reduce that though? Yeah. You can't, so it'd be 13.9. So the inversion of this is 13.9. Or I guess this is the inversion of 13.9, really. Anyway, whatever. So, or I guess both, but okay. Yeah, I'm so close to being done analyzing these. So, this sixth, this third, which is 2319 or something, just flips over to make this sixth, which would be a major sixth, but slightly this is slightly sharp, or pretty sharp really, minor third, so this would be a pretty flat major sixth. So it would literally be the I don't even have to look it up now. What's double 19? It'd be 38 over 23. Will be this interval. Cent off, cent shy of that. No, not even. It was even closer than that. Less than a cent shy. I think it was half a cent off or something. And then this is the flip of this mystery interval, which I'm willing to bet there's some some kind of representation of this. If we just go to a higher limit, probably find it. I wonder even, there's a couple ways to search for it. One, I'm definitely not about to do because it would take too long, but that would be to load up a bunch of harmonic series intervals and analyze the synth values and just go way up so that you get the like go up past the 5th octave and all that into the 6th, 7th, 8th octave until we find a good approximation of that interval. That would take a long time. I don't really feel like doing that right now. The other thing that I want to try right now is go to ZenWiki and see if I can't find an article about thirds. Just see if there's something. Just a bunch of just third stuff. I'll click a page or two, see if something pops up. That ain't it. It's a comma. 242. We're on the hunt for 372. Or something really close. No. So much of this stuff is 11 limit. If I look up 11 limit thirds, it's going to pop up. Does 11 limit have thirds? Yeah, sure does. What's an 11-9? Is that not a third? Maybe that's a super major second. $264. Look for 372. 380 is not too far. 380. 380. Man, I want to hear 380. All right, I think I'm giving up on that particular interval. I think I do need to like look at the 6th and 7th octaves and stuff. To find a good representation, if it even exists. If it doesn't, I think that makes it even cooler. I kind of like that it's just a mystery. So we have a corresponding mystery 6th. So again, here's the mystery 3rd. Oh, sorry. And there as well. And then starting here, we have the mystery 6th. And you know, they do sound kind of similar, don't they? Maybe not. Yeah. And of course, these are just, you start on the 3rd and go up to the next version of whatever that was on the bottom, this or this. And yeah, and then the 869 is just going to be the flip of that 1. And then we had the 662, which is that 111 limit interval. And then the flip of that was this 537, which was that 11 limit fourth. So yeah, that's all the intervals. And obviously not nearly as much as are in the full Nautilus. So this is a lot easier to think about. And yeah, I didn't, after having jammed a little bit on this, I didn't realize I was going to go back into the theory stuff, but what I'll do tomorrow when I stream again is probably review this briefly, and then using our knowledge of kind of what intervals are available, we'll expand this out more to chords. So we already looked at, we have the major, then we have this, it's kind of like a minor chord with a minor fifth or sub fifth. It's like a minor, I don't even know what you would call that. It's like a minor or something. Minor sub, something like that. We have 3 of those interesting minor wolf chords, whatever you want to call these. I don't know what to call it. And then we have a couple actual minor in that 23 prime limit minor third. So tomorrow we'll look at this column, which they're all minor sevens, but this one's sort of neutral. This one's pretty much just Pythagorean, pretty close to the 12 Edo. So the one chord with the 12 Edo seventh does not have the major third or the regular fifth. So you do have that option. Anything you can conceive by combining values on this chart is in the full set of 29. So if you were to go, oh, I wish that, like right now I'm kind of thinking, oh, I wish the Pythagorean seventh had a Pythagorean fifth. I mean, it does in 29. But since this is just a 7-note subset, we don't have it in the subset. Okay, but yeah, I need to get going. But yeah, anyway, not sure if anyone watched. We had a chatter earlier on Twitch, actually. It's probably the first time I've had a viewer on a music stream on Twitch. So that was fun. Alfredo M. I don't know if you stuck around. Probably not. And if so, I'm not sure for how long. But thanks for checking out the stream. If anyone else came in, I actually don't keep my eye on the Twitch chat. I keep it on the chat, but I don't look to see who's watching. So YouTube says one person is watching right now. I don't think that's me, but anyway, thanks for watching, whoever you are. If you're me, I guess thank me for watching. Yeah, thank me for making this, I guess. And yeah, I'll plan on being back tomorrow. But yeah, 2 hours is not a bad amount of time, but I don't mind going longer. I just really have to go tonight. I have to go to bed. So yeah, when we come back tomorrow, we'll keep going with this. Maybe listen back to some of those jams. Keep analyzing this and try to get a little, since it is such a small scale, I'm not too scared of getting a little systematic with this compared to what I normally do. I normally just plug in notes on a piano roll and just tweak all the notes until it sounds good, which is a good way to do it, but this way I can kind of learn more of the theory, which I feel like I should. I'm kind of at that point where I need to start pushing in that direction again. So yeah, we'll get a little more systematic, try to come up with some more music in this tuning, maybe come up with another patch if we have time. But for tonight, that's all I'm gonna do. So have a good rest of your night or day or whatever. And thanks again for watching. Hope this was, at the very least, educational to anyone who's interested in microtonal music and theory.